This is an interesting problem. So, first of all, y could be positive or negative. It could be, for example, positive 5 or negative 5. But since we're going to square them, it doesn't really matter. So we might as well just consider the positives. More importantly, what is the highest value that y could have? What is the highest positive value that y could have here? And this is where there's a mathematical trap. If people are just thinking in terms of numbers as positive integers, as if the only possibilities for y would be 4, 5, and 6, well then the highest value would be 6. And of course 6 squared plus 5 is less than 50. But here's the thing. Y could be any decimal. It could be 6, it could be 6.5, it could be 6.9. Y could be 6.9999999 with 9s going all the way around the block. Okay, let's say 1,000 or 2,000 9s after the 6.9. And so that would be a number astonishingly close to 7. In fact, when we squared it, of course, it wouldn't be exactly 49, but it probably would be something very much like 48.999, and then 9's halfway around the block, and then maybe a few other digits. But the point is, we could get something very, very close to 49. We certainly could get the square root of 48. Y could be the square root of 48, because that is a number between 6 and 7. It is certainly less than 7. And then y squared would equal 48. And then y squared plus 5 would be 53. So it is certainly possible, for example, if y is 6, column A is smaller, column B is bigger. But if y is the square root of 48, that makes column A bigger. So we can make some choices that make column A bigger, and some choices that make column B bigger. And because the relationship changes for different choices, the answer has to be D.